All right, good afternoon. So my name is Levi Adams, and I'm here today to talk about my dissertation research on glioblastoma multiforme. Glioblastoma has actually recently gained a lot of attention after Senator John McCain was diagnosed with it just before he had a big important vote in the Senate this year. It's actually the most common brain tumor that's found in adults. Unfortunately, as well, it's actually one of the deadliest cancers that there is. As you can see in this MRI, the tumors are extremely large and they actually grow very fast. The median survival time after diagnosis with one of these tumors is 14 months until death. And the 2-year survival rate is less than 5%, which is actually lower than pancreatic cancer. And right now there is a urgent unmet need to find therapies to help slow or stop this disease because there's only one FDA-approved treatment, and it actually doesn't work very well. To help answer this, I've been doing research into the Knox enzyme class of the Knox enzymes. These proteins are important mediators of various signaling pathways in the cells, and they actually themselves are almost never mutated, so they've been really overlooked in research. Although all of the mutations that cause this disease usually have at least some of their activity through these proteins, so I think they act almost like a bottleneck. And if we can maybe block these enzymes, we can slow a lot of processes all at the same time. Specifically, we're working with the hypothesis that these enzymes allow stem cells to actually become new blood vessels and keep feeding the tumor growth. To address this issue, I've actually had to develop a new model of this cancer. The current models for glioblastoma usually involve mice that have genetic mutations. The problem is that these mice, once they're prone to cancer, they get multiple kinds of cancer. It's not always the right kind, and they don't live very long. Also, the actual human disease, most people don't have these mutations permanently in their whole bodies. It's just the few cells that actually start the tumor that have the mutations. And so what I've been working on to develop is a method to induce a tumor with very specific mutations in otherwise healthy adult mice, which is what happens in humans. And so I've actually engineered a non-transmissible, we'll say safe virus to carry these different things that I can inject directly into the brain. And so when I do this, I can actually model a new tumor, and hopefully we can identify therapeutic options, and whether or not it's even the Knox enzymes, this can provide a new platform for either myself or other researchers to find ways to intervene in this disease. Thank you.